All right. Thanks for coming today. I'm Thomas, and this is Charles. Tenderlove tweeted this earlier today. It was originally Ben and Jerry of Ben and Jerry ice cream. For those few people that don't know what JRuby is, I'm going to talk just a short period of time about it. First of all, we're a Ruby implementation that tries to be as compatible with CRuby as we can, but our differences are a little more interesting. And most of those interests or differences come because we're built on top of the Java platform. So we have multiple garbage collectors, and you can tune those and make your application perform better. It runs on top of Hotspot, so we have this best in the world sort of native JIT that does dynamic profiled optimizations, which makes JRuby run fast. There's lots of tooling, and probably the most important difference is we have no global interpreter lock, so you get to be able to use native threads and fully utilize all cores from one Ruby process. And Java runs absolutely everywhere. It's really easy to go and pull in Java libraries. Any Java library you pull in, you can access that Java class as if it was a Ruby type, and you'll feel like you're programming in Ruby. So let's say that you have a Ruby gem, and there's just some problem that the Ruby gem's not solving. You can go and find the Java equivalent version of that, pull it in, and potentially solve your problem. As I said, it's easy to go and call into the Java language, but you can call into any other JVM language that's out there, like Clojure and Scala. Okay. So there's two supported versions of JRuby today. There's JRuby 9000, which we're going to be talking about today. We're tracking the latest version of CRuby, which right now is 2.2. At the end of the talk, we'll mention our plans for supporting 2.3. We have a maintenance release of JRuby 1.7, which supports either Ruby 1.8.7 or 1.9.3, and you can just pass in the command line flag to specify which version you want to run. So these are the big bullet points for our latest major release, JRuby 9000. As I said, we're tracking the latest release of CRuby. We have a brand new runtime called internal representation. We've been working on it for years. We'll be talking about that later in the talk. Most of the I/O now is bypassing the JVM and going out to C so that we can better be compatible with CRuby. And Oniguruma has been fully ported, so the transcoding engine is fully over and all the data tables. So M17N should be bug-free now. And you might be curious about our version number. It started as a joke, and it became reality. True story. But the only thing anyone ever cares about at conferences is performance, so we're going to give a performance talk. But before we go into that, I'm just going to give a quick overview of our new runtime, internal representation. We were tired of working with an abstract syntax tree. We wanted to have something that we worked with that represented Ruby semantics more directly. And we also wanted to make a traditional compiler design so that if you took a compiler's course at university or you read a compiler's book, it's the same nouns, verbs, algorithms, so you should be able to just help and contribute to make JRuby better. So in JRuby 1.7 and earlier, we would go and parse the source and create an abstract syntax tree. Now in 9000, we have these additional compiler phases. So during semantic analysis, we'll translate that syntax tree into a set of virtual machine instructions. We'll create some other data structures like a control flow graph. After we've made that, then we'll go into this optimization phase where we'll go and run a set of pluggable compiler passes. And then we might make some other data structures like a data flow graph. Then we go into the interpreter phase where we interpret our machine instructions that we've made. And after that's been running a little while, we decide it's time to go and generate some Java bytecode. And then we generate that bytecode, and then the JVM takes that and then makes it super fast. So here's our first look at instructions. For the Ruby code on the left, here's the instructions on the right. I'll just go over a few quickly. On line 0, we check the arity to make sure there's 2 required arguments. Otherwise, we raise an exception. On lines 1 and 2, we bind the parameters A and B to the 0th and 1st required argument. We have special variables. On line 3, here we're receiving any block that's passed into the method. On line 5, we have a line number instruction. If we happen to go and throw or raise an exception, then we know which line number the error occurred on. Let's see. Line 8, we're calling the plus method on the receiver A and giving it the argument C, A plus C. This is a register-based design as opposed to YARV, which is a stack-based one. But I think it's pretty easy to read. During optimizations, we run a set of compiler passes. I'll just go through a simple session showing how we reduce work, just one way that we make JRuby a little bit faster. So the first thing we notice is that B is not accessed. And in fact, we don't actually do anything with the closures. So through dead code elimination, we can eliminate those instructions entirely. Next thing we notice is that C is assigned to this constant value, and we only read that constant value. So let's let's propagate that constant. So now we can eliminate that instruction. In addition, that call now knows that it's calling against a fixed num, so we can potentially optimize that more. The last thing we'll notice is that there's 2 line number instructions in a row, but there's no way we can raise between those 2, so we'll just kill one of those off.
Okay, so I'll talk a little bit about some actual shipping optimizations that we've done that are in the current release, 9.04. So first off, we always wanted to be able to compile blocks as well as methods, but JRuby 1.7 would only compile method bodies. So if the block was in a method and the method compiled, then it would get to JVM bytecode and run fast. It's much easier for us to actually do blocks independently now. Here's some performance comparisons. This is MRI running a regular method and a defined method, which has a block. And then JRuby 9.01, obviously the performance isn't where we want it to be. And the reason why even the regular method is slow is because the benchmark itself had blocks in it, and those blocks didn't compile. So the benchmark was still interpreting too. With the change to actually compile blocks, compile procs and lambdas and so on, now JRuby 9.04's performance is more like we'd want it to be. So methods are running as fast as they should. The benchmark is much faster than running in CRuby. But we can see another problem here. How many people use define method in code? I mean, Rails uses it all over. Lots of libraries use define method. So this performance difference is something we wanted to fix. So there's 2 different cases of define method here. The first one we would consider a simple define method. It doesn't use any state around the block. It's just the block. All the state it needs is inside there. The second one is what we'd call a capturing block. It uses some state from outside of the define method. In this case, it's sending a modified method name based on the name variable. So a simple case and a capturing case. And we use define methods all over. They're very convenient, but both of these have quite a bit more overhead than a regular method. Here's a comparison, and this affects MRI as well. So there's MRI and JRuby with a normal defined method, just a def method, and then both forms of defined method. And of course, JRuby is doing well on regular methods, but we all have a major hit from define method. And these are used so often, this is something we decided we needed to fix. So what we've done, when we can see that a define method does not capture any state, the simple form, we will just compile it as a method. We actually treat it as a normal method body, not with all the overhead of a block. We also want to do this for the capturing case. Usually, if it captures state from outside, it's capturing it as a constant value. So we should be able to propagate that and do the same thing. But that's future work that we're going to be doing. And so this is the new state of affairs in 904. The simple define method is now almost getting to the point, almost as fast as a regular method definition. That's really excellent. And obviously, we still want to fix the define method with capture. But with a little bit of work, hopefully in the next couple releases, all define methods should get pretty close to normal method definition performance. And that's great. The last big one we did, we've talked previously about how expensive exceptions are for JRuby. In large part, this is because on the JVM, generating an exception backtrace is very expensive. Lots of work has to be done. But unfortunately, exceptions are used often as flow control. They are thrown and ignored. Everybody's done this in code. We don't particularly like this pattern, but we can see that it's very convenient. You don't care if there's an exception raised. You just want to try this and then continue on. And so we run into this all over the place. We had a bug report that csv.rb had very poor performance on JRuby, terrible performance, something like 100 times slower than running on CRuby even. And the problem we ran into is that when you turn on value converters, it does this cascading set of blocks. So it'll try the integer converter, and if that fails, it'll try the float converter, and then it'll cascade through a few others. So at the worst case, every value that was coming out of csv.rb, or being parsed by that library, was generating 3, 4, 5 exceptions with full backtraces. And of course, this also hurts MRI, but for us, it was catastrophic, terrible performance.
Yeah, we're something like 20 times slower than MRI at generating backtraces.
So we needed to figure this out. And so this is the new state of affairs. This is JRuby before we did the exception optimization on the left, and JRuby after. So that foo rescue nil is what we're benchmarking here. And this is just about 2 orders of magnitude faster now. The way we did this is by looking at the code, inspecting our IR, and if we see that it's an exception that's ignored, we set a flag. We don't generate the backtrace when it's thrown, and so it's much cheaper now, considerably cheaper. And this gets our performance on libraries like csv.rb back to where it should be.
Okay, so that's some things that we've done recently for our last release of JRuby 9000. Now we're going to talk about some stuff that we're working on right now. Hopefully in a few months it'll be in production. The first one is inlining methods. For people who aren't aware of what inlining a method is, when you make a method call, if you're always calling to the same thing, just pull the body of that method back to where the call was, and then you don't have to set up a stack frame and allocate this extra memory. You don't have to go and set up the parameters for making the call. You don't have to deal with the return value. And there's several other good reasons why you want to inline methods, but pretty much all compilers and all dynamic runtimes have to inline methods to get good performance. So here's an example. I'm not showing IR on the right, but for the program on the left, the right would be the inlined version. So we'll pretend that this is IR, but it's a lot easier to read in Ruby. So on the left, we're just counting down from 1,000,000. Every iteration, we call a method called decrement1. So this is a prime candidate to be inlined. If we look on the right, we can see the while loop's a little bit bigger. At the top, we have this guard. We want to make sure that nothing's changed. So long as nothing's changed, then that inlined body can just execute and we don't have to make a call. But if that guard starts to fail, then we just have to fall back to doing method dispatch again. So we can see that this is really conceptually simple. It's a very simple snippet of Ruby code. And thankfully for us, we have the failure case baked in as the else branch, so we don't have to de-optimize. We do eventually want to de-optimize, but we can't today, so this is a good thing right now. And this works both in the interpreter and the JIT. It's only worked in the JIT since Friday afternoon, so it's very, very new.
All right, so the next thing we want to be able to do, once we can inline this code, once we have that loop pulled together, we want to start doing some specialization, numeric specialization. So, of course, in Ruby, everything's an object, but that's not quite true. Numbers are a special type in CRuby. They're called a tagged pointer. Floats and fixed nums usually don't have the overhead of an object. But on the JVM, we have to pick. We have to pick either a lightweight number, a primitive value, or a reference. And when we compile to the JVM, we can't switch back and forth. We have to know ahead of time which one we're going to use. So in order to get good performance for numeric algorithms in JRuby, we need to be a little bit smarter and start specializing fixed nums, floats, and so on to their primitive Java equivalents. So here, a simple loop again. We can see that we've got I equals 0, so we're probably going to be continuing to use that as a fixed num. We're comparing I with n, so n is being passed in. It's probably going to be a fixed num as well. Do something, so whenever we call this method or we inline it, we're probably just going to pass this along as a fixed num, as a numeric value. And then we're incrementing I. So in each place where we have these variables, we should be able to tell after a little while, after code has run, that these can be optimized into regular 64-bit long values. So what we would be able to do, and we have prototypes of this working, we can take this code and just guess and say, okay, it looks like you're only ever using these as fixed nums. So let's say that n is a long value, and let's say that I is a long value. And now all the rest of this code doesn't have to work with objects. It can run much faster. The benchmark we had was a Mandelbrot generator that did numeric specialization for floats, and it was something like 30 times faster. 35 times faster than running with regular fixed num code, which was already a couple times faster than CRuby. So we're getting to the point of being able to run like Java speed on this stuff. So this is still kind of prototype right now, but we're hoping to have this released within the next several months for JRuby 9000 release.
In order to enable the last two optimizations, we need a mechanism, and that mechanism is going to be with our profiler. For every call site that we have, we go and keep track of which methods it's calling and how many times it's calling it. I realize I've seen several talks in the last few days that mentions call site, and I'm not sure everyone knows what a call site is. It's literally just the place where a call is occurring. So object.execute is a call site. So you're welcome. So when we profile, we're really interested in things that only call one thing. We're interested in monomorphic call sites. Once we actually start calling multiple versions of methods, then there's less opportunities to have big wins with this. Although some runtimes do, we're just interested in the monomorphic type. So when we find a bunch of monomorphic call sites, we look for the hottest ones, or the ones that have been called the most, and then they become candidates for optimizations. Like the numeric specialization that Charlie was talking about, if the type is a fixed num, but more likely it's going to be inlined. So we do have a working profiler. Again, the JIT only started working on Friday afternoon. The overhead for keeping track of this information's about 2%. So it's not too bad, and it can easily pay for itself, as you'll see. And right now, the profiler is only deciding to do method inlining. We'll add numeric specialization later once we work out the kinks. And that same star is up there. It's fragile and buggy, but it works for a lot of test cases. So I'll just share you one benchmark. It's a micro benchmark for sure. But I think it represents a very common pattern in code. So in the big loop method, we just have this method so that we can constantly call the small loop method. And we're passing in a block, which is something we often do in Ruby. In the small loop method, we're basically calling yield several times. You could pretend that this was array.each or any method in Ruby enumerable, but for the sake of the state of our current runtime, this is all isolated into separate little methods. So how well does it work? Woo! So I don't want anyone to walk out of here thinking that we're now running 4 times faster. It's only in one test case, and it happens to be maybe JRuby's worst case because we've never been able to inline blocks back to the call site. And so we get rid of all the overhead of invoking a block. And JRuby invokes blocks, I think, almost twice as slow as MRI, something. So we're getting rid of something that's pretty expensive for us historically. So we will get faster, but this was a joke.
All right, so the last section I want to talk about, we do a lot of work on JRuby to make it faster, but we also work very closely with folks on the OpenJDK team, folks at Sun, folks at Red Hat, and so on, or folks at Sun. A moment of silence for Sun Microsystems. Folks at Oracle and folks around the world that do OpenJDK. And they're constantly working to make the JVM better, even using us as a test case. When they do optimizations of the JVM, they will ask us for benchmarks, and they will run JRuby to see if the new version is running faster. And they're also adding some features that are important for us. So I'll talk about a couple of those. FFI has been a great addition to the Ruby world. I've been very excited that folks are starting to pick it up, use Ruby code to call into C, rather than writing C code that we can't connect into JRuby. So we're working with OpenJDK folks to add a native FFI to the JVM, to OpenJDK. It's called Project Panama. It's bridging north and south, Java, JVM world, and native world. And this is actually in progress now. Native support for FFI in the JVM. It can look at a header file, generate all the code bindings for you, and then the JIT actually understands those calls to native code. So when it compiles Ruby code or any JVM bytecode, it can actually optimize it just like regular C code would. So here's the old state of affairs before FFI libraries started to come along. Had to write a lot of extra code. Had to write the JNI side, had to write the C side on the native side of this. We use a library that was developed for JRuby called JNR, Java Native Runtime. And so this one does a lot more work for us. It has all of the C code, the native code is already available. It uses libffi to call into the library, and then it generates some stubs for us on the Java side as well. So all we have to write is the user code. But this is a lot of layers to go through to get from Ruby or C code down, or Ruby or Java code down into a native library. With Project Panama, it'll look more like this. The FFI will be built into the JVM. So your Java or Ruby code up at the top just tells Panama that it wants to call, for example, getPid in libc, and it will make sure that binding works, tie it directly into the compiled code for you, and when it jits it down to assembly code, we'll actually see compiled, JITted Ruby code doing native calls to C functions. So you can actually write C libraries or call into C libraries just as well on top of the JVM in either Ruby or Java. So the other big one is startup time. By far the biggest challenge for us on JRuby, probably the main thing that keeps JRuby from seeing more adoption. And it's a very hard problem for us to solve. Everything in JRuby starts cold. The parser starts cold, the interpreter is cold, so all the things that you do in JRuby have to warm up. Whereas in CRuby, the parser, the interpreter, all of the core classes, they're already C. They're already fast native code. We're also starting to use more Ruby to implement JRuby itself. And that makes things even worse for us, because now we've got cold Ruby code that needs to be interpreted, needs to be compiled. You can see where we're going with that. How bad is it? So this is a comparison of CRuby Startup with JRuby Startup for 3 common tasks. So -E1, basically just booting JRuby itself. gem -- list, and I think I had about 100 libraries installed at when I did this test. And rake-t in a Rails app, which will boot up all of the Rails framework and get a list of tasks. And so you can see that we're many, many times slower here, and this is a big reason why people tend to stay away from JRuby. So to help this, we added the dev flag. So the --dev flag disables some JRuby optimizations internally that you don't need at development time. It turns off some optimizations in the JVM that can make it take longer to warm up. And this helps considerably. So here's JRuby running those same things with the --dev flag, better than 50% improvement in most of these cases. So if you're using JRuby or the startup time is scaring you away from JRuby, definitely remember this flag. This is the best way to get good startup right now.
But don't run it in production.
Yes, don't run this in production because, like I say, it turns off optimizations and so on. But it can make development a lot less painful. So what the JVM folks are doing, they understand our pain, and they are working on an ahead-of-time compiler for OpenJDK. The idea is that it can take JVM bytecode, so JRuby itself, for example, and precompile it down to native code. So we don't have that cold execution at the beginning. We'll start with hot, fast, native code right away. Even better, it will still save all the information it needs to continue optimizing that. So it's not just a one-time compile to native, it will then also proceed to run the JVM JIT and make things fast eventually. So the fastest possible startup with the fastest possible production runtime code. And this is where it is right now. It's still kind of prototype work from the Oracle guys. But you can see rake-t is the long bar here is JRuby with no flags, no settings. --dev is the third bar down. And then the 2 at the bottom are basically the ahead-of-time work that the JVM folks are doing. And remember, this is still good to run in production. This is still going to be fast and optimized, just like the full-on JRuby, but it's beating our --dev flag. And this is going to improve. So the future for this, ahead of time is partially done. It might be available in Java 9, but we are going to work with the Oracle folks. They're going to make sure we have access to it in whatever form once it's ready to be used. There's also many tweaks that we can do to JRuby itself, so this will optimize better. We've been going back and forth with the JVM guys. The ideal is that all code that runs in JRuby should be native when it starts up. So we won't have any of those major startup issues anymore, and we should be able to get closer to CRuby startup time. Just wanted to say thank you quickly to all the many companies, all the folks out there that are using JRuby. This is why we come do these talks. We want JRuby to be there for you when you need it. If you're using MRI and you don't have any issues, it's great, keep using MRI. When you need what JRuby has to offer, performance-wise, native thread-wise, like these companies, maybe you'll have a look at JRuby then. I have a bunch of stickers that I'd like to give away. I put some on the table out there, but you can come grab some afterwards as well. And since we have a little bit of time, Tom will talk a little bit about the 2.3 work we're doing.
I wish I would have put the issue number. We have a tracking issue on our GitHub project that lists the missing features and which features we have. We're rapidly adding those features. Charlie went and put out a call on our bat phone for JRuby contributors, and we've been getting multiple pull requests a day for the missing features. We have the hope that by the end of January, version 9.1 or 9100 will be out, and it'll work with 2.3.
I'd say we probably have about a third of the core class features are done, and Tom's already started working on some of the parser stuff. Like the lonely operator is working on our 2.3 branch. And I think we have some time for questions. Thank you.
Thank you, JRuby team. Yes, we have some time for questions, several questions. Anyone?
Oh, yeah.
So your intermediate representation, is that an SSA?
It is not. The actual temporary variables and local variables are in that form, but it's not in general.
Okay.
So,
Just curious.
yeah.
We thought about it. The guy that we had work with us had done optimizing JVM JIT for his PhD work many years ago. And at the moment, we haven't found a good reason to go all the way to SSA with it.
So this is a really simple question, but I think most of the people here would like to know. Let's say I want to get started using JRuby tomorrow, and yeah, I want to use that dev flag. So simplest way would be to say RBM install JRuby, and then I just go to my Rails project, for instance, and then usually I just go with bundle exec Rails S. And in that case, how do you use that dev flag? What is the easiest way?
So all of the JRuby command line flags that we support, you can put in an environment variable, JRuby _opts. And that's probably the easiest way. Just make sure that you unset it when you start benchmarking things. But yeah, that's what I usually do, is put it in an environment variable.
And I'm glad you asked that question, because that's the most common mistake that people make, is they put --dev and then bundle re-execs and then loses that.
Thank you.
There's one back there.
Thank you for the talk, and thank you for making JRuby. I have one question that goes a bit in line with the previous question, which is, if we go towards a workflow of using MRI for development and JRuby in production, would you actually recommend doing that for starting? If we do that, is there something we should be careful about? Any problem that you guys see in doing that?
Right, so basically the question about if you want to use MRI as your development environment and then deploy on JRuby, it's actually fairly common. There are a number of companies that do it that way. The main things to watch out for is if you get C extensions that start to sneak in on the development side, you're going to want to make sure that you're running regular testing against JRuby to pick those up. But otherwise, we don't get a ton of compatibility bugs anymore. With 9000, we did a lot of work to catch up, and it's fairly common for folks to have a mixed environment, JRuby and MRI.
So my question is that, is it possible to change --dev option dynamically? I'm asking this because I've created one command which has run command, yes command, and preview command. And preview command needs to run quickly and finishes almost immediately. So we want to use --dev. But for run, we want to have JIT. So what I want to do is to change the flag when I know the command.
Right, and these are Ruby scripts that you're running, I assume.
Well, right now I'm using shell script to check the command.
Okay.
So it is possible right now, but I want to use Ruby for the entire program.
Right, so you can turn off JRuby's JIT and optimizations dynamically after it boots, but the part that turns off the JVM's own optimizations, that doesn't work. And unfortunately, that's where we get the biggest boost, is turning off those JVM optimizations. So you can do part of it dynamically.
But we do actually have a bug with programmatically changing that flag. That was reported like a few weeks ago. I was going to say that you reported it, but maybe not. Okay.
Thank you.
Yeah, I guess the time is up.
All right, thank you.
So thank you, JRuby team.